The very first thing we're going to do with our microcontroller is actually not use the microcontroller functionality at all. Instead, what we're going to do is we're going to use the microcontroller as a power source. So, the Arduino costs like, $25. So it's a $25 power supply. It's reuse of technology, right? So I've got an LED here. I've got some wires. You could probably get away with just one, but I'm going to use. If you want to use two, you can do that too. I've got a switch, and then I'm going to use one of these resistors. And this is, remember I said that you've got like 10 of one kind and 5 of another? This is the one that's 10, got 10 on here. So you'll notice that these have the colors on here. The way that you read them is you start on the far side from the gold or silver band. And so this is going to be orange, orange, brown. So these first two tell us a value. So this is 3 and 3. And this third one right here, this is a multiplier. So this is 100. So I can figure out from here I've got a 330 ohm resistor. The gold band tells me the tolerance, so how much percentage it is tolerant in either direction. The gold band is 5%, so this could be 5% in either direction. It's totally fine. We are not building medical devices, so if it's a little bit off, it'll be okay. The resistor resists the flow of electrical energy. It keeps us from providing too much voltage and current to our LED to keep it from burning out. So what I'm going to do is you may have some tools at home that'll be helpful for you. I've got this pair of wire snips right here. And I'm just going to cut off the leads a little bit here. You don't have to do this. I'm only doing this so that it's slightly more visible, right? And I'm actually doing this way before I actually use the thing. So what I'm going to do is I'm going to build a circuit that interrupts the flow of electrical energy. And when I press the button, it'll close the circuit. Electricity will flow across the element inside of the LED, the diode, and turn it on. So first thing I'm going to do is I'm going to take my switch, and you'll notice on the switch that there's these like little teeth-like things, and that they kind of like grip in. You can think almost of like a claw, right? So that claw wants to straddle the center of your board. So it'll go in like this, right? If you try to do it in a different orientation, it's not going to sit right. You'll notice that this is, again, it's sitting flush with the board, right? So it's not like sitting on top of it. It's down in there. Next thing I want to do is I want to, I don't even need these wires. Maybe I'll use them later. Next thing I'm going to do is I'm going to take this LED and I'm going to bend the edges just a little bit. So these are then going to sit inside of my board. Obviously, it's a lot easier if you're going to, if you've got those long legs. They're way more malleable. And I'm going to connect one end of this to power. This is my power bus line, right? So I'm connecting one end into power, and the other end I'm connecting to this bus row that has that connects to my switch. Right? So now I've got voltage that will pass through this resistor. There'll be a voltage drop across that resistor. And then the switch currently is interrupting the flow of electrical energy. On the other side of the switch, I want to put my LED. And you'll notice that the LED has two different size legs. The longer leg is the one that connects to power. The shorter leg is the one that connects to ground. If you ever find yourself with an LED that has that the legs are the same size, you'll notice that there's this little cutout on the bottom of the LED. So it's like it's a circle, and then with a flat edge. The side with the flat edge, that's the side that would go to ground. So I'm going to take. So this is the side that has power, right? So what I'm going to do is on the other part of my switch right here, I'm going to stick this in. It can go. My LED could go into any one of these bus holes along this row, right? So I'm going to put it in here. Then I'm going to put the other end into my ground line, just like that, right? So now what we've got, and I didn't even need to use these wires. Lazy circuit building. So when we complete this, we will have power coming through here, across the resistor, through the switch, and then to light up the LED. So I'm going to take a USB cable here, right? And I'm going to use this to power my microcontroller. I just plug it in. When I do, you'll see this little light come on right here. That'll let me know that it's got power. Nothing's happening, right? Nothing's supposed to happen when you first plug this in. If you see something happening, unplug it, figure out what's going on inside of your circuit, because it shouldn't be lit up yet. So now when I press this button, the LED turns on. It's lovely blue, right? So when I press this, I close the circuit. Electricity can flow through the LED, and now I've got a light. So this is my hello world of electronics. This switch could be anything that is electrically conductive, right? So if I wanted to, for example, make a switch that had, see, I do have a use for these wires. If I wanted to make something that was a switch with where these wires connected to something at the end, right? So maybe that was like 2 pieces of aluminum foil on cardboard, right? And then when those pieces of cardboard connected with the aluminum foil, these then turned it on, right? So here we can see this again, plug it in, no light, and then when these 2 conductive pieces of the switch touch, the LED turns on, right? This is essentially what's going on inside of the switch itself. So again, if I connect these to anything electrically conductive, they will turn on. I could stick my tongue on this. It would probably close the circuit. Not going to do that. Kind of gross. So, yeah, experiment with something with this, right? Take two leads like this. Wrap them in tinfoil, right? Have one connected to, say, maybe like a knife, and the other one connected to a fork. And when you touch the 2 together, the light turns on. Maybe you could do it so when you sit down in a chair, you compress 2 pieces of aluminum foil together, and that turns on a switch, right? There are many different ways of thinking about this. Think about, like, what is a switch that you don't use your hands for? Can you step on it? Can you lay your head on it? Can you smile and make it work? What other sorts of interactions are there other than just sort of like pressing something to make a switch close? But there you go. This is your hello world of electronics. Also, now your board, so let's see. There we go. Once again, your board, even without any of this stuff, you always want to leave these 2 in. That'll help you make sure that you've got a bus line down here, and you'll be all good for any sort of future stuff that we wind up doing.